Hello, this video is going to talk to you about properties of inequalities and solving linear inequalities. But before we get to that, I didn't quite finish one example from the first video. So let's talk about this. This is a linear equation. X plus 2 times x minus 3 equals x minus 3 quantity squared. And what you'll want to do is, to solve this, you'll want to review multiplying polynomials together or binomials together and their properties. But I'm going to assume that you know how to do the FOIL method here. So x plus 2 times x minus 3 is actually going to equal x squared minus x minus 6. And then x minus 3 quantity squared is x squared minus 6x plus 9. Now, what we're going to do here is we're going to notice that we have an x squared on both sides. So what I can do is, let's say I move this x squared. Remember, I can transpose it to the other side, and then I would get x squared minus x squared on the left, and it disappears from the right. Well, then basically the x squareds will cancel, and I'm left with just the minus x and the minus 6 on the left, and the minus 6x plus 9 on the right. And now we can finish this with what we learned in the first video. Minus x minus 6 equal to minus 6x plus 9. I can just transpose the minus 6x to the other side, and it becomes plus 6x. Then I can transpose the minus 6 from the left side to the right side, and it changes sign as well. And so now I have minus x plus 6x, which is 5x, and 9 plus 6 is 15. And then all you have to do is divide both sides by 5, and you get that x is 3. Okay, now we're going to delve into solving linear inequalities. And when we do that, we're going to use some properties that are very similar to properties of equations. But let's take a look at these. Now, I'm going to use A is less than B. You could also write a similar set of properties for A is greater than B, A is less than or equal to B, or A is greater than or equal to B. The key is be consistent throughout the problem. If you start with less than, then you want to finish with less than in most cases. And if you start with less than or equal to, you want to finish with less than or equal to. So the reason I said in most cases is obviously when you multiply or divide by negatives, it'll flip the inequality over, which we'll see in a minute. But let's start with less than. If A is less than B, then A plus C equals B plus C. So if you look over here, you'll see I have x minus 5 is less than or equal to negative 3. So all I have to do, just like I did with equations, all I have to do is add 5 to both sides. And then the 5's will cancel. Now you could do the transpose method as well. So x minus 5 plus 5 just gives me x, which I have here, and then minus 3 plus 5 gives me 2. Now, if this had been a plus 5, I would have just subtracted 5 from both sides. So I could do either one, because remember, subtraction is a form of addition. So you could say, well, if this was a plus 5, then I'm going to subtract 5 from both sides. Or you could say I'm going to add negative 5 to both sides, which is basically the same thing as subtracting 5. Now notice these two properties here that I have highlighted for you, they look like the same property, except there is one small detail. This property only works if C is greater than 0 or if C is positive. And this property only works if C is less than 0 or negative. So if A is less than B, then A times C would still be less than B times C if you multiply by a positive number. So let me show you this example. If you have x over 3 is less than 7, and you want to isolate the x, well, to cancel this 3 right here, you're going to multiply this by 3. So let's say we multiply the left side by 3. Well, this property says if I multiply the right side by 3, since 3 is positive, then the inequality will stay less than. So then when I multiply both sides by 3, the 3's cancel, because 3 over 3 is 1, and then 3 times 7 is 21, so I have x is less than 21. But if I were to have x over negative 3, then what I need to do is multiply this left-hand side by a negative number. I'd have to multiply by negative 3 to cancel it. And notice that when you multiply by negative 3, I'm going to flip the inequality over. And there's a very simple reason for that. For instance, let's say we all know that negative 2 is less than 1. What would happen if you multiplied, say you took some random negative number like negative 3 and multiplied it by negative 2? And then on the other side, let's say you multiply negative 3 times positive 1. Okay, well, let's see what happens. Well, we're going to get 6 over here, positive 6, and over here we're going to get negative 3. Now, ask yourself this. Is 6 still less than negative 3? No, 6 is greater than negative 3. So therefore, we had to flip this over. So anytime you're multiplying both sides of an inequality by a negative number, you've got to flip over the inequality. So, again, negative 3 over negative 3 is 1, so this is 1x on the left. We flipped it over, so we get greater than, and on the right, we get negative 21. Similarly, we have, if a is less than b, then a over c is less than b over c, as long as c is positive. But if we divide both sides by a negative number, notice the c is less than 0, notice that the inequality flips around to the other way. It goes from less than to greater than. So if I wanted to solve 5x is less than negative 30, then I know I've got to divide both sides by 5, and since 5 is a positive number, the inequality will stay less than. So it will be x is less than negative 6, because 5x over 5 is just x, negative 30 divided 5 is negative 6. But if I wanted to solve negative 5x is less than negative 30, then now I've got to divide both sides by a negative 5, and when you divide by a negative, remember this inequality's got to switch direction, so it's going to switch to greater than, and so I'm going to have x is greater than, and negative 30 divided by negative 5 is 6. So I have x is greater than 6 would be the solution for that one. Now let's look at how we could use these properties to solve an inequality. Now here I used a less than or equal to inequality, and remember all I have to do is just be consistent and use less than or equal to throughout the problem. So if I have 3x minus 7 and I want to get rid of the minus 7, I'm going to add 7 to both sides. So kind of same as the equation properties. And then when I add 7 to both sides, the left-hand side, minus 7 plus 7 cancels and just leaves me with 3x. The right-hand side, 23 plus 7 is 30. Now, I've got to divide 3x by something so that it becomes x. Now, what do I divide by? Do I divide by a positive or a negative number? Right, I'm going to divide by a positive 3. So divide 3x by positive 3. And since I'm dividing by a positive number, the inequality stays the same. It stays less than or equal to. And 30 divided by 3 is 10. So my final answer, since 3x over 3 is just x, my final answer is x is less than or equal to 10. And this down here shows you the interval, the number line graph. So a bracket means that we're going to include the 10, okay? And then the green shaded region shows me that I include everything less than 10 as well. Okay, this next one, I have x over minus 3 minus 5. It is greater than negative 1. So what I want to do here, I want to get rid of this negative 5. So to get rid of that negative 5, I can just add 5 to that side. But if I add 5 to this side of the inequality, I must add 5 to this side. So now negative 5 plus 5 is 0, so I'm just left with x over minus 3. And over here, minus 1 plus 5 is 4, so I have x over minus 3 is greater than 4. Now, what am I going to do to get rid of this negative 3 that's in the denominator? Yep, I'm going to multiply this side by negative 3 so that it will cancel the negative 3 in the denominator and give me 1 or 1x. Now, notice that if I multiply both sides by a negative 3, remember what this inequality must do. This is important. It must change direction. So it's got to go to less than. And now, negative 3x divided by negative 3 is x, and negative 3 times 4 is negative 12, so I have x is less than negative 12. And here's the graph of that. Notice I used a parenthesis here because this implies that that negative 12 is not part of the solution. Just everything less than negative 12 is part of the solution. Okay, let's look at a couple of more that are a little more complicated. And if I don't get through the fourth one, you can just view it on the video and see my steps. Okay, so here I have 4x minus 6x plus 1. First thing I want to do, just like equations, I want to combine everything on each side. 4x minus 6x is minus 2x, so I have minus 2x plus 1. Here I distribute. 5 times x is 5x. 5 times minus 4 is negative 20. So I have 5x minus 20 plus 3. Notice I didn't change the inequality. It's still greater than or equal to. And then here I can combine minus 20 plus 3 and get minus 17. So I have minus 2x plus 1 is greater than or equal to 5x minus 17. Now, notice I want my x's to the left and I want my numbers to the right. Well, remember the transpose property I gave you earlier. If I want this 5x to the other side, I can just move it to the other side as long as I change its sign. Same thing with inequalities. I can still do that. So move the 5x over here, it becomes minus 5x. And to get rid of this 1, I'm going to move it to the other side, and it becomes minus 1. So now, on the left side, I can combine my x's and get minus 7x. On the right side, I can combine my numbers and get minus 18. Now, I have to divide both sides by negative 7 to isolate the x, and because I'm multiplying by, or dividing by a negative, the inequality switches from greater than or equal to less than or equal to. And then negative 18 divided by negative 7 is a positive number, so I have 18/7 on the right, and then of course this is just going to be x on the left, so I have x is less than or equal to 18/7, and again, there's the graph. Okay, this last one, I'm going to go ahead and get rid of my denominators here. Notice I have a denominator of 4 and 6. So I can eliminate my denominators by just multiplying everything by 12. 4 and 6 both go into 12. So if I multiply 12 times 3/4, I get 36 over 4, which is 9. If I multiply 12 times minus 3x, I get minus 36x. If I multiply 12 times minus 5x, I get minus 60x. If I multiply 12 times 1/6, I get 2. And remember, since 12 is a positive number, I don't have to monkey with the inequality. Now, I can do the transpose thing here where I move the minus 60x over here and it becomes plus 60. And then I can take the 9 here and I can move it to the other side here and it becomes minus 9. And so I get 60x minus 36x on the left and I get 2 minus 9 on the right. Well, 60x minus 36x is 24x. 2 minus 9 is negative 7. Now all I have to do is divide both sides by 24, and since 24 is a positive number, then I don't change the inequality, so I get x is greater than negative 7 over 24. And then you can see the graph here. Notice I used the parentheses on this one because it was greater than. Over here I used a bracket because it was less than or equal to. Anytime you have the equal to, you use a bracket. Anytime you have a greater than or a greater than or less than, you use a parentheses. So greater than would be everything to the right of this parentheses. And less than or equal to would be this bracket and everything to the left of that number. Now, if you were really using a true number line with numbers on it, you actually would want to make sure you put these numbers in their appropriate places. And that pretty much completes this video on solving linear inequalities.